Hello, in this lesson we are going to talk about percent yield. Percent yield is by definition a measure of the efficiency of a reaction carried out in the laboratory. We can also apply this concept to a few other areas in life which we will use as an example shortly. This is an extremely important calculation when we are dealing with chemistry in industry, as it tells us how efficient our production process of a chemical happens to be. To understand percent yield, we need to define a couple of other terms that we will use when doing percent yield calculations. The theoretical yield is the maximum amount of product that could be formed from a given amount of a reactant. So basically, we're looking at the reactants that we have and we're figuring out what could be the maximum possible yield in a perfect world if everything goes exactly according to plan with no error. The actual yield is the amount of product that we actually form in a laboratory. So this is where we go through a process. We've calculated what we should make. The actual yield doesn't always equal what we ought to make because there are outside influences affecting this production. This is the equation that you're going to use to determine percent yield. It shouldn't look entirely unfamiliar to you. Most of you, when you receive a test back in school, will use this exact same calculation to figure out what your percentage is on the test. The actual yield in this case would be your score that you've earned. The theoretical yield would be the maximum possible score on the test, and then you multiply it by 100 to get your percentage, which is the way syllabi normally list the grade breakdown or distribution. So this should be a familiar process to you. We need to look at how to calculate theoretical yield. This is perhaps the trickiest part of this, though you should be familiar with this. So we're going to look at the production of ammonia. What is the theoretical yield in moles if 0.25 grams of nitrogen gas reacts with excess hydrogen? So we want to get to moles as the first step. Whenever we're comparing two different chemicals in a balanced chemical equation, we need to show or get to moles as the first step. So we take 0.25 grams of N2 times in a line, use molar mass as the second step in this problem, and we have 1 mole of N2 over 28.01 grams of N2. We're not where we need to be for the end yet, so we do another times in a line. And now we want to go from moles of N2 to moles of NH3. Here we pull the molar coefficients from the balanced chemical equation, stick them into this conversion ratio. So we see that it's a 2-to-1 ratio. And then now we're in moles of NH3. And that's what our question has asked. What is the theoretical yield in moles? So we put an equal sign. I've gone down to the second row here, and it comes out to 0.018 moles of NH3. You may need to convert to another unit at the end if it asks for it in grams, but it just depends on what the question asks for. Now that we have our theoretical yield of 0.018 moles, if the actual yield is 0.015 moles, what is the percent yield? We'll take this equation, take our actual yield, 0.015, over our theoretical yield, 0.018, multiply by 100, and our answer is 83%. As always, check the comments of this video to see where in your textbook you can get additional practice problems.